let's look at some special situations that can come up with our solutions. So in these, we're going to go ahead and do the final step. This is the last thing that we need to learn today, which is how to check our solutions to see if we have any extraneous solutions. We'll start out the same way. So we can isolate our absolute value on one side. In fact, it's already been done. And our solution, notice that it has an x in it. It's 4 times x. Let's go ahead and break into our two different equations. So we will have 2x plus 12 is equal to 4x, or 2x plus 12 is equal to negative 4x. Again, identifying a positive and a negative solution based on our original isolated absolute value that is now two separate linear equations. All right, so let's solve each of these. I'm going to choose to move the 2x over to the right, leaving me with 12 is equal to 2x, and dividing by 2, I will have x is equal to 6. The second equation I'll approach the same way. Negative 2x on both sides will give me 12 is equal to negative 6x, and dividing by negative 6 leaves me with x is equal to negative 2. Now we're going to implement the final thing, which is checking our solutions to see if one of them might be extraneous. You really need to go ahead and do this anytime that you see variables on both sides and you're dealing with an absolute value, whether that variable is in absolute value bars or not. I just wanted to get you guys used to it before I introduce this last final thing. So our check, we need to take our 6 and evaluate our original function at x equals 6 and see if we come up with a true statement. And then we'll do the same thing at x equals negative 2. So we will go into our very original equation, substituting 6 everywhere that we see x. So we'll have absolute value of 2 times 6 plus 12 is equal to 4 times 6. Let's go ahead and simplify this. So if we have 2 times 6 is 12 plus 12, and so that is 24, still in absolute value bars. Until now, I know that the absolute value of 24 is 24. Let's finish off the other side. 4 times 6 is simply 24, so I can bring that down. I get at the very end a true statement. 24 is equal to 24. A number is always equal to itself. So that means that x equals 6 is a solution. Let's go ahead and check x equals negative 2. This time we will substitute negative 2 in everywhere we see x. Again, we are evaluating to see if we actually have a true statement. So plugging in negative 2 for x. This will give me negative 4 plus 12 in absolute value bars and negative 8 over here. This is absolute value of 8, which is 8. And 8 is not equal to negative 8. Those are opposites of each other. Equals are not, or opposites are not equal. So I'm going to say not equal and put a big old X there. That is not a true statement. And so what that means is that x equals negative 2. Remember, that's what we were evaluating, is x equals negative 2. That is not a true statement. It's an extraneous solution. It's extra. It appears to be a solution, but it doesn't satisfy the original equation. And so our only solution in this case is that x is the set of numbers, and there's just one in the set. It's just 6. All right, let's go ahead and look at another example and see what type of special situation we might run into here. We do only have absolute value on one side, so it is isolated. There's nothing outside of the absolute value bars on that side. And our solution contains a variable again. So this is our positive solution. We'll break into two pieces, both a positive and negative, to take into consideration that what's inside the absolute value could be either. So our positive is 5r plus 3 is equal to 2r. Our negative is that 5r plus 3 could equal negative 2r. Again, identifying a positive and then the opposite, a negative, on those two sides, and sticking with our original isolated absolute value, 5r plus 3. Let's go ahead and solve these two equations. So I'm going to go ahead and subtract 5r from both sides, leaving me with 3 is equal to negative 3r, and dividing by negative 3, I'll get that r is equal to negative 1 when I simplify that. Let's go ahead and take a look at the other one. We can subtract 5r from both sides. Let's make that an r and not something that looks kind of like a v. Negative 5r. We'll end up with 3 is equal to negative 7r. And dividing by negative 7, we have that r is equal to negative 3 over 7. All right, let's go ahead and check this one. I kind of have a sneaking feeling that neither of these is going to be a solution, and the reason for that is notice that we have an r value of negative 1 here, and if we plug that in, we're going to end up with a negative on that right side. We would end up with a negative 2. Remember that we can never have negative values as the output of an absolute value once it's isolated. Let's go ahead and prove that to ourselves, though, by going forward with checking this. If you happen to recognize that type of situation without doing a final check, that's okay. But this is just absolute confirmation right here. All right, let's go ahead and substitute negative 1 everywhere we see r in our original equation. We'll have absolute value of 5 times negative 1 plus 3 is equal to 2 times negative 1. This gives me a negative 5 plus 3, which is negative 2, and the absolute value of negative 2 is positive 2. Remember that it's a distance. Distance is always positive. This, as I mentioned, ends up being negative, and so those are not equal to each other. Big ol' X and a not equal sign. Let's evaluate for an r value of negative 3 over 7. So plugging in, we'll have absolute value of 5 times negative 3 over 7 plus 3 is equal to 2 times negative 3 over 7. Simplifying inside, we have negative 15 over 7 plus 3 in absolute value bars and a negative 6 over 7 on the right. Continuing, if we evaluate this fraction and the addition, we're going to end up with negative 6 over 7 in absolute value bars is equal to negative 6 over 7. It's looking promising, however, you've got to remember the definition of absolute value. Absolute value says what is negative 6/7 distance from 0, and its distance is a positive 6 over 7, which is not equal to a negative 6 over 7. So this is no good, this is no good, both are extraneous. And if both of these are extraneous, then that means that there is actually no solution. Let's look at one final example. This time, notice that we have absolute values on each side, so I'm just going to grab one of these and say that it's our isolated one, and the other one will become our solution that we'll take the positive and negative values of. When we split this, it's going to be x minus 3 is equal to x plus 6, and x minus 3 is equal to negative x plus 6. Remember, the negative applies to the entire side, so we need to use the grouping symbol of parentheses when we get rid of that absolute value. Let's again continue to identify x plus 6 as our positive. This will be our negative solution. And of course, we had our original isolated absolute value, x minus 3. Solving, I'm going to subtract x from both sides to move the x from the left hand to the right hand side. But notice what happens here. Not only do the x's on the left cancel, but so do the ones on the right. I have completely lost my variable, which means that I'm left with an equation that says negative 3 is equal to 6. Negative 3 can't ever equal negative 6 or positive 6, either one. So negative 3 is not equal to 6. So this already is not a good solution because this is a false statement. We cannot ever say that one number is equal to another number. It's only equal to itself if we're comparing numbers to numbers. So false statement, we don't even need to check that one and go through the check step. Let's check this other one though. Let's go ahead and solve it because that negative sign introduces something a little different here. Remember to distribute the negative to both pieces, and then this time when we subtract x from both sides, our variable doesn't disappear. I'm left with a negative 3 is equal to negative 2x because the negative x and negative x add, and then minus 6. Then I will add 6 to both sides. This will leave me with 3 is equal to negative 2x. And finally, that x is equal to negative 3 over 2. Negative 3 over 2. All right, remember that just because we were able to solve this and get a value, it doesn't mean that it will actually make the original equation true. So we're going to check. We only need to check x is equal to negative 3 over 2. We never got to an x equals in our first equation. So we're going to plug that in. Negative 3 over 2, again, plugging in for the x value. We're evaluating at this potential solution number. And then that's going to be equal to negative 3 over 2 plus 6. When we simplify this, we'll get negative 9 over 2, or you could also call it negative 4.5. And then over here, we're going to get a positive 9 over 2. The absolute value of negative 9 over 2 is a positive 9 over 2. Remember, absolute values are always positive. And positive 9 over 2 is also equal to 9 over 2. This one is good. Our final answer is just our one answer, that x is equal to the set of the one number, negative 3 over 2.